That was absolutely fascinating. And it's really interesting. Over the last while, we've had different accounts from different viewpoints about where we are with AGI. It's a conversation we're going to continue tomorrow. But lots of warning signs about where this technology is taking us and the assumptions that we make in terms of its availability, its scalability, its performance, and what sort of level of output we can expect from it in complicated environments. We were at the World Summit in Amsterdam, and Mark Heaps, who's head of Grok, not Elon Musk's Grok, but Grok, the AI inference engine. So they basically have found a way to really implement a high quality, a lot of speed in their AI engines. He did a demo, and he was talking about this video that's not miles off what we heard there from Gary, where he had just a plain video feed of a basketball game, and the AI was watching the basketball game, was able to identify who was scoring points, who was ahead. It was able to identify the players and whether or not they were playing well while watching this in real time. It was an extraordinary demonstration of the speed at which we can get AI working if we apply different techniques. So that was something that I really learned from it, that we can get inference at quite some speed. To talk about, some of the things that Gary was speaking about there. Tomorrow we have some really great highlights for you, Sue. I hope you come back and join us nice and early. We have Professor Sue Black. She's the OBE and Professor of Computer Science, Director of EDI at Durham University. She has a huge amount of experience and a fantastic speaker. We'll also hear from His Excellency Sheikh Mansour bin Khalifa Al Thani. He's a founder and chairman of MBK Holding and a chairman at Tamkeen. We'll have lots of more speakers renowned in AI as well. But we are finishing off today with probably one of the finest speakers of the day, coming from the second best country in the world, that's Ireland. I will say that with deference. We're delighted to have her with us. Her name is Janet Adams. She's Chief Operating Officer at SingularityNET. And she's going to be talking about AGI, what we've been speaking about here, the quest for human-level machine intelligence. Please welcome Janet.
Thank you, Jonathan, from the second best country in the world. How's everybody here from the best country in the world? Yay, nice to have you. Thank you so much for waiting. Thank you for being here for my talk. I appreciate your attention and your time. And hopefully, this is going to be the most exciting talk you've had all day. Nicely warmed up by Gary there, who said we absolutely must start using symbolic AI. Today's deep neural networks are simply not cutting it. They're in no way delivering the promise. They're in no way exploring the possibilities of artificial intelligence to dramatically change and solve humans' issues and problems. So I'm here to talk to you about AGI. Who here knows what AGI is first? Okay, I'd say that's about a third. Let me get started. So today's AI industry, and I'll come on to what AGI is, I won't forget that thought. Today's AI industry is driven by a particular type of AI called deep neural networks. You probably all know what they are. They form large language models. They form all the large models that are in use in the world today and probably generate about 99% of today's economic value being driven by AI, which you might say sounds fantastic, but you look the other side, AI is just not generating economic value anywhere near its potential today. We're dominated by big tech. We're obsessed with these deep neural networks. We're not really yet using these technologies to help the people who need them most. Big tech is primarily producing technology for the top 1% of our population on the planet. And guess what? They're not the people who need it most. 25,000 people die of hunger a day in our planet right now. While I'm talking, I don't know, 600-700 people will die of hunger completely unnecessarily. As humanity, we are not effectively or fast enough addressing these issues. Why? Because with artificial intelligence, we're stuck on these LLMs. Now, they seem super clever. Who here uses LLMs? Show of hands again. All right. Oh, a little over half of you are using LLMs. They're useful, right? If you're in a rush to write an email or create a specification, job profile, bam, they can bang it out. But what they can't do is reason. They have zero reasoning capability. All they do is statistically predict what is the next most likely token. That token could be a word, it could be an image, it could be anything. Purely statistical analysis, no creativity. As Gary mentioned, no logic, no reasoning. These are not technologies to take humankind into the next era, into our AGI revolution. Yes, they're very, very intelligent. They seem to be able to predict very well. But they don't address our challenges. And what use is a technology that doesn't address our challenges? Make the world a better place, bring along people in developing countries, solve for diseases, cure diseases, alleviate suffering. Now I'm going to tell you what AGI is. AGI stands for Artificial General Intelligence. It's a phrase that was first published by our CEO, Dr. Ben Goertzel, visionary founder of SingularityNET and board director of the Artificial Superintelligence Alliance. He's been working for 3 decades with a team of scientists to develop AI that can generalize. And what does that mean? It means being able to learn, as Gary as well warmed up very nicely, it means being able to learn in one domain and apply what you learn in one domain to a different domain. It means being able to create outside of the training data set. Because if all AI can do is reproduce what's in its training data, how do we move forward? How do we develop? How do we get to artificial general intelligence? And that's what my talk is about today. It is not a simple problem, because if it was, we'd have done it already. But we're getting very, very close. So, difference between narrow intelligence and general intelligence. Narrow intelligence pre-trained on specific data sets. Large data sets, of course, these days. Only can do what it's programmed to do, which some may say is a good thing, but we'll come back to ethics and regulation. Can only work in its original scope, can't be creative, can't be dynamic, can't learn and move forwards. Requires human expertise. Our AGIs are going to go past that point, probably. And they're just derivative. They're simply matching existing patterns. What is AGI going to bring us? Well, the ability to reason and learn. Reason in artificial intelligence opens up its usefulness and will be the flame that lights the blue touch paper of intelligent automation and robotic automation right across the world, which today still doesn't fulfill its promises. It'll be able to think strategically. It will be able to make decisions. Now imagine when we have an AGI that's making decisions, and I'll come on to the ethics, but an AGI that understands the ethics and needs of very, very broad groups of people and is making decisions not for profit, not for war, not for power, not for greed, not for personal status, but can actually make decisions based on group, globally collated ethics that serve the greatest number of people. You know, they say power corrupts. Absolute power corrupts absolutely. I heard a statistic last week that it takes 15 years for a normal person to turn into a monster. That wasn't the word they actually used, but for a normal person to get their head turned once they get power. 15 years of sycophancy turns everybody into some kind of a self-obsessed lunatic. That's not going to happen to our AGIs. They can work with nuance, they can manage and coordinate these narrow AIs for us, because there's a place for them in particular narrow use cases. And it will be able to make major leaps in understanding science and technology. We foresee Nobel Prize-winning scientific and medical discoveries could be every 5 minutes once we have AGI and ASI. So very, very powerful. I'm going to cycle back to who we are. Who has ever heard of the Artificial Superintelligence Alliance here? Yes, thank you very much. Thank you very much. Very pleased to hear that. Well, ASI, I'm very proud to be a board director of ASI together with my fellow council members. We are a coalition of decentralized AI leaders and pioneers and innovators who are here to tackle big tech dominance and together to pool our resources and win the AGI race. Because the AGI race is the hottest race on the planet today. And the wealth generated by AI will be unprecedented, enormous, faster, vaster than any wealth creation period in our history. We want to get in there and we want to win this race, and we're looking good. And we want to make sure that that wealth generation, that this final giant industrial revolution shares the wealth through all the strata of society. That's what we care about, and that's what we're doing. We also care about super, super clever advanced technologies. So we're working on ethically sourced and managed data. We have decentralized infrastructure and governance. Really, really, really passionate about global inclusion in both our teams, in our executives, and in all of the wider developer groups who are developing on our systems. We have a shared vision to accelerate and scale up decentralized AI, AGI, and ASI, and we're building towards a unified stack. We have an ASI token, which is called FET, and a value of $7.5 billion at the time at which we merged earlier this year. And what are we doing together? Led by Ben Goertzel, father of AGI, we're taking our open source Hyperon OpenCog community platform, and I'm going to tell you what that is in a moment. We're taking all of our technologies, we're combining them with Fetch's amazing agent infrastructure, with Ocean's data protocol, and with Kudos, who run decentralized compute. Because what do you need? You need an AGI platform, you need agents that can talk to each other. Imagine these agents will be able to speak to each other and tell them what data they have seen. Imagine a robot encounters sand for the first time and wants to know what sand is, and another robot has never encountered water. With agents, they can speak to each other and they can say, what is this thing? I've seen it before, I know what it is. What is this? I've seen it before, I know what it is. And the growth in knowledge and the growth in power and potential of the AI becomes exponential at this point. That's what we're working on. Okay, who likes a technical deep dive? Because I can go as fast or as slow through these technical slides. Anyone craving some deep techie? Or you'd rather it be understandable? 1, 2, 3, 4, 5. Okay, we've got, oh, yeah, okay. We'll go a little bit technical. So at SingularityNET, our founder, he decided age 3 that he was going to build a robot that was smarter than Data in Star Trek. He's just turned 58 now, so he's been working on this all his life. He and his team have pioneered this OpenCog Hyperon platform and have been building it. The first release was actually in 1998, called the WebMind engine. And the same teams have been building it using the techniques that Gary just told us about, that he said have been ignored and derided in technology until today. He always said symbolic AI was important. We always knew symbolic AI was important. And so we have built what can be thought of as an AI platform that enables every kind of AI to integrate and work together. Evolutionary learning, probabilistic reasoning, any form of logic systems, classic deep neural networks, attention allocation systems, all the classic logistic regression and support vector machines, everything. Because our theory is that AGI is not going to come from one rigid technology, particularly deep neural networks, but from the interaction of many of these technologies together in an emergent behavior way. We have a metagraph, which is a knowledge graph, a very highly advanced knowledge graph called distributed atom space. We do work with deep neural networks, reasoning and learning. So this creates like a kind of chemical soup of AIs from which life can emerge. Sorry, they say, oh no, you can still read it. So what does it do? We're aiming for cognitive synergy. We are working with all of the perception hierarchies, vision, auditory, with language comprehension, with understanding. So imagine, and I would challenge anyone to find any other project as far advanced in these technologies as us on the planet today. We can take processes like memory, reasoning, procedure learning, and we can match them with these perception hierarchies. And we can create intermediate steps. What if this? What if that? Create an intermediate symbolic state, and then work some new AI on it. And I love this bullet, goal-oriented and non-goal-oriented cognitive dynamics working together. So what does that mean? I'm going to do another quick audience check. In an average day, how much of your time would you say is spent pursuing planned goal activities, and how much of it is spent spontaneously interacting with your environment and doing new things that you hadn't planned? And could you ever imagine splitting the two? Okay, long question. I possibly won't ask, but think about it, right? I know me, I have my goals for the day, I'm always going to go to the gym, and then something spontaneous arises and stops me from going. But not all the time, luckily. So that's how the human mind works, right? We have our goals, we know what we want to achieve in our life, but at the same time we're able to spontaneously interact and we're able to change what we're doing based on incoming information. And this is the cognitive synergy, and this is the approach which we are taking for our AGIs, because unlike deep neural networks, we don't want them to be stuck, only able to follow one goal. We want them to be able to take new information in. We want them to be able to adapt. We want them to be able to serve humanity to the best of their ability at any one moment in time, dynamically. We're applying these in robotics. We've got some beautiful 3-foot-high mind children robots that I'd love to talk to anybody about that we're piloting and rolling out next year. We're experimenting in bio-AI, looking for cures to some of the most debilitating diseases that humanity faces. We have digital twins. Neoterics is our new word. I think it's our new word. Does anyone here know what neoterics is? I'm pretty sure it's our new word. And that is the interaction of AIs together in a game-type environment. And anyone who's a Minecraft player can go play with one of our proto-AGI agents, which is playing Minecraft and able to learn new environments very, very fast. We're applying them in finance, we're applying them in maths. We can apply them really right across vertical markets because it's a general purpose technology. Of course, we use evolutionary algorithms, we use evolutionary probabilistic guided evolutionary program, and that's deeply embedded into our neural symbolic techniques and in our OpenCog Hyperon platform, all able to work with and interface. For example, we're now looking at interfacing Moses, which is our evolutionary learning program, with PLN, our logical program, and see what happens when you breed AIs, breed schools and families of new programs, and then apply a logic and reasoning suite of algorithms to them. Challenges, of course, attention allocation and memory management. Though many of you will know attention is all you need, applying that attention to large data sets and in resource-constrained environments is a challenge which we're overcoming with our ECAN memory management and attention economic networks. So what are the benefits? OpenCog is flexible, it's scalable, it supports all these diverse cognitive architectures. Our Primus architecture, it integrates inputs and outputs within a cognitive loop. As I mentioned, balancing structured, goal-oriented activity with self-organizing spontaneous behaviors. We have our own bespoke, in-house developed meta-functional programming language, which pulls it all together and enables all of these parts to speak with each other. We have symbolic and sub-symbolic AI components. We have the distributed atom space, which is our dynamic metagraph, and it enables seamless integration. This is our distributed atom space. It's a knowledge graph. I'm sure you all know what that is. It's a highly advanced knowledge graph metagraph. And this is our path through our cognitive framework, through our acceleration that we're doing at the moment. I was in a retreat last week with our technologists. They don't want me to give the numbers out, but we're seeing up to 5 million times faster processing. Sorry, researchers, I didn't say that. I didn't say in specific what, but these are 5 to 7 orders of magnitude in acceleration and in scaling that we're currently on the brink of at SingularityNET and ASI. Of course, we need hardware, and we have the world's first designed AGI supercomputer. Now, an AGI supercomputer is very, very different to an AI supercomputer. It doesn't need all these giant GPUs doing feed-forward backpropagation. It needs much more concurrency, and so the GPUs need to be close to the CPUs. We need low latency, and we've built it, and we're currently looking for a home for it somewhere in the Middle East, if we're interested in having that discussion later. So, in ASI, we've got a number of exciting roadmap features we're rolling out soon. ASI Create, which is our platform for AI developers and AGI developers. ASI Train, which we're very excited about, enables people to own their own foundational models and train them in domain-specific areas. And we have ASI Learn, which enables AIs and AIs to learn with each other. So on that point, here's the incredible team I get to work with, and I'd like to say a very big thank you for staying to the end, everybody.
Janet, that was
Thanks,
amazing.
Jonathan.
Thank you so much. It's always great to be on stage with a fellow Irish person.
And yourself,
It seems like you've followed this quite well through, right? We were talking back and forth on this stage about how close AGI is. I mean, this is a huge level of complexity you're talking about with ASI. How far away do you feel like we are? Because when I've met people who don't seem that intelligent when I'm working with, and I feel like AGI is like 15 years ago in terms of ChatGPT. How close are we now?
So I'll give you 2 predictions from 2 of our ASI board members. Trent McConaughey, who's CTO of Ocean, he's predicting 1 to 3 years for AGI. And then ASI, which is superintelligence, which is smarter than humans, within 3 years after that. Our own CEO, Dr. Ben Goertzel, he's predicting 2 to 4, 2 to 5.
Oh my
but we
God.
are expecting to see major AGI breakthroughs next year as we start to scale up, because we've built the tech stack. Now we're just scaling and accelerating. So we're expecting to see major breakthroughs next year, and then towards the end of 2026 is when we could start to see some real magic happening.
So what do the people in this room need to do to think about being ready for artificial superintelligence? Are there things that they can do to plan for that? Because I feel like knowing that it's coming, there are steps we should take to be ready for that, even if we're just running enterprises or running governments.
Well, so first off, get your data and your house in order. Have your data, be ready for when these powerful technologies come along. Second, Stop running down the rabbit hole of LLMs. They are not brilliant tools. They don't deliver ROI. They hallucinate. They make mistakes. Cut free from LLM thinking and start thinking neural symbolic, evolutionary programming, and how you can build wider skill sets in your data science and technology teams that can work with a much broader range of technology. I think that's the best start. And also make sure all of your ethics, regulatory compliance, data management, etc., is all in place, and get ready for massive large-scale transformation. This won't just change industry, it will completely reform it.
I want to ask one final question before I let you go. I know it's late. You were so good for staying.
So I'm delighted to be here with these lovely people who say...
What is the impact of... Did you hear about Google's Willow chip announced today? So
I have not. I've been busy getting ready for this talk.
So they've announced a quantum chip that has gotten to the level of low error, which they've considered to be acceptable. Some of the stats they were saying is in 5 minutes you can do what 10 septillion years of current supercomputers can do in terms of compute. What does the potential of real commercial application of quantum do to ASI?
It accelerates massively, and it scales massively the potential. So when we have quantum computing, AGI will be so close behind.
Right.
Get ready for it.
It's fantastic to have you, Janet. Thank you so much for coming.
Thanks
Janet Adams from SingularityNET and ASI.
Thank you, everyone.
I hope you've had a wonderful day. Thank you so much to Janet. She's been brilliant.